In the following video, we're going to examine how to solve and graph inequalities. Remember, the steps for solving inequalities is the same as the steps for solving equations, except that when you multiply or divide by a negative number, you need to flip the inequality symbol. So let's attempt the first example. 6x plus 3 is greater than 5x minus 2. So I am going to get the x's on the same side by subtracting 5x from both sides of the inequality. That gives me x plus 3 is greater than negative 2. And then I'm going to solve for x by subtracting 3 from both sides. So x is greater than negative 5. So that is the solution set to the inequality. To graph it on the number line, what I'll do is I'm going to put negative 5 in the middle. I'm going to fill in a couple other numbers. Let's do negative 4, negative 3, and then we'll do negative 6 and negative 7. And so when graphing, remember, if it's greater than or less than, we use an open circle. And when all the x values are greater than negative 5, then that represents all the numbers to the right of negative 5. And so there is our solution set graphed on the number line. Now let's try number 2. Negative 0.4p is greater than 10. So I'm going to get p by itself by dividing by the coefficient of negative 0.4. So if I do that to the left side, I'm going to do it to the right side. Now what happens here is p is all by itself, but I notice I divided by a negative number, which means that my inequality symbol switches from a greater than to a less than. And then what we're going to do is do 10 divided by negative 0.4, which gives us negative 25. Same idea. So that represents the solution as a solution set as an inequality. I'm going to put negative 25 on the number line. I'm going to put a couple values to the right. So negative 24, negative 23. I have negative 26 and negative 27. And so this one, again, since it's less than, is going to be an open circle. And I want all the values less than negative 25, so that would be all the values to the left of 25. So to solve, we follow the same setup as before, except for when you multiply or divide by a negative, you flip the inequality symbol. Let's look at examples 3 and 4. Now this one's a little more unique. We have negative y is greater than or equal to y plus 6 over 7. And so we need to figure out how do we go about solving this problem. We have y's on both sides of the inequality symbol, and we need to get them by themselves. But this y plus 6 is being divided by 7, so this y plus 6 still has something attached to it in a way. So what I'm going to do is I'm going to multiply both sides of the inequality by 7. And what that's going to allow me to do is it's going to allow me to get rid of this denominator of 7. So 7 times negative y is negative 7y is greater than or equal to, and now I'm left with just the numerator, y plus 6. So now I'm going to solve. I'm going to subtract y from both sides. So I get negative 8y is greater than or equal to 6. And now when I divide by negative 8, I need to remember, since I'm dividing by a negative, to flip the inequality symbol. And then 6 over negative 8 becomes negative 3/4. And so the solution set is represented by the inequality y is less than or equal to negative 3/4. So to graph negative 3/4, I find this the easiest way to do it. I'm going to start, since it's negative, I'm going to put my 0 here. I'll put negative 1 in the middle, and I'm putting negative 2 on the outside. And I'm dealing with fourths. So I'm going to split each of these in half, and then split the halves in halves. And so now I create a number line that goes by fourths. And so when y is less than or equal to negative 3/4, here's negative 3/4. Since it's less than or equal to, it's a solid circle, and the arrow is pointing to the left. And so there is the graph of our solution set. So let's see if we can use the same idea or something similar to it over here. If you have x over 3 plus 2 is less than or equal to 4x minus 7, we know we need to get the x's on the same side, and we know we need to get the numbers on the other side. So to go about this one, how do we approach it? There are two methods. The first is to use the same idea, to try and get the fraction with the variable by itself. So the first method we'll do is we'll subtract 2. That will get the x over 3 by itself, and I'm left with 4x minus 9. And what I can do next is I can multiply both sides by this fraction, the denominator part. So I multiply the left side by 3, but when I multiply the right side by 3, every term has to get multiplied by 3. And so therefore our 3's cancel, and I'm left with x is less than or equal to 12x minus 27. I'm going to subtract 12x, and I get negative 11x is less than or equal to negative 27. And so when I divide by a negative 11 here, a negative flips the inequality sign, and a negative divided by a negative is a positive. So x is greater than or equal to 27 11ths, which if you type in 27 11ths in your calculator, it's approximately 2.45. So let's start. I'll do a 0 here. I'll do let's say 4 here. So in the middle is 2. Split the middle, there's 1. Split the middle, there's 3. And so if I'm doing greater than or equal to 2.45, it's a little under halfway between 2 and 3, and the arrow is going to the right. So that represents one method of solving this inequality. Now let's examine another approach. So I'm going to take this information, let's shrink it down, put it over here so we can still see it and compare our work together, and take the original inequality that we were given. Now the other approach is to realize, what does x over 3 represent? And really, x over 3 represents 1/3 x. So really you have 1/3 x plus 2 is less than 4x minus 7. So then what I can do is subtract 1/3 x from both sides. That allows me to bring the variable over to the other side. So I'm left with 2 is less than or equal to 11/3 x minus 7. Add 7. So 9 is less than or equal to 11/3 x. And now I'm going to multiply both sides by the reciprocal of the fraction coefficient, 3/11ths. That allows me to cancel out the 3 in the bottom and the 11 in the top. So therefore I have 3 times 9 is 27 over 11 is less than or equal to x. And when you're dealing with inequalities, you always flip this so the x is on the left. So then x is greater than or equal to 27 11ths, which if we look is the same answer we got above. So there are multiple ways sometimes to approach a problem. You need to choose which technique is easier for you to see.